Okay, from the derivative of sine equals cosine and the derivative of cosine equals negative sine, we can derive all of these. This one is going to come up so often you're going to have it memorized, particularly when you get to calculus 2. You're going to need this one a lot. This one comes up semi-regularly, enough that you kind of want to remember it by the time you get to calc 2. These two, I don't even have memorized. All of these we can derive. So I'll derive these two, and then you could derive these two on your own if you wanted to. So derivative with respect to x of tangent of x is the derivative of sine over cosine. That's what tangent is, sine over cosine. That's a quotient rule. So I'm going to use quotient rule on this. That would be derivative of the top, derivative of sine is cosine, times, leave the bottom alone, minus the derivative of the bottom. The derivative of cosine is negative sine, times, leave the top alone, all over the bottom squared. Remember, this notation, cos squared of x, means, so let me recall here. If I were to write this, that means take the cosine, get an answer, and then square it. Okay, let's look and see what we have here. That would be cos squared. And then I got a minus times a minus. I've got a plus, a sine squared, all over cos squared. But wait a minute, remember your Pythagorean identity, sine squared plus cosine squared is just 1. That's 1 over cos squared. But wait a minute, cos, 1 over cos is just secant. So 1 over cos squared is secant squared. So we have just now proven this derivative formula. Okay, for fun, we'll do this one too. So the derivative with respect to x of secant of x, I would think of this as 1 over cosine. And then I could, exactly like I did above, I could do quotient rule on this, but I would rather do power rule. I would think of this as the derivative with respect to x of cosine of x to the -1 power. Not inverse cosine. If I write this, that's fancy mathy notation for inverse cosine. That is not the same thing. That button on your calculator that looks like that, that's inverse cosine, arc cosine. That's not secant. That's why I'm being very explicit here, and I'm writing this as something to the -1. I'm not using this kind of notation here. That would look confusing. Okay, now I can do chain rule on this. The derivative of anything to a power would be bring that power down, leave the inside alone, and drop that power by 1. So -1 minus 1 is -2 times the derivative of what's inside. The derivative of cosine is negative sine. So these negatives would cancel out, and I would get sine divided by cosine squared. Because this cosine to the -2, I would just bring that down. And we're done. That's the derivative of secant. And you're like, but that's not the formula you circled. Yeah, it is. And I'll show you. But that's the same thing. Like this would be another way to memorize derivative of secant. Or we could think of this as sine over cosine times another 1 over cosine. So I could split this cosine squared into two separate cosines multiplied. Hey, that's tangent there. And 1 over cosine is secant. So we have now proven the derivative of secant is tangent secant. Or secant tangent. You can write it either way. These two proofs are very similar. You could try those on your own.